Assalamualaikum and hi, we are from group number 3. So today we would like to present our group assignment title, which is focused on the refinery power plant explosion in terms of code of ethics that we have learned in this semester. So before we start, let me introduce our group members. So first one is myself, Muhammad Amir Aiman bin Muhammad Karim, DD220089. Second one, Ahmad SYAHIDI bin ROSLI, DD220080. Third one is HANIS binti HUSIN, DD220085. And the last one, Taranjit Singh, anak lelaki BAHJAN Singh, DD220083. So let we move on to the introduction. And right now we are in the introduction. So in this introduction, I will be explaining what is the introduction. So first, what is the power plant code of ethics actually? So I'll be explaining first. The power plant code of ethics is the outline, value, and norm for employees focused on the professionalism, honesty, and safety. It emphasizes adherence to safety rules, integrity, and environmental responsibility. It encourages truthfulness, openness, and legal compliance while promoting emission reduction, waste management, and sustainability energy practices. So second is this group project assignment focus on the code of ethics in the power plant. So specifically, the coffin vapor explosion in Kosion City in Taiwan on 31 July 2014. This explosion occurred due to an underground pipeline leak of at least 90,000 kilograms of propylene. So as you can see at the left, this is the figure of the underground pipeline path. So I will be explaining. So this underground pipeline path which pass through downtown, chemical plant and railway maintenance houses, which is the fault that live in the Kaohsiung city in Taiwan, cause and big explosion at two power plants in Taiwan, which is the Taiwan CPC Kaohsiung Refinery and the LCY Tashi plant. And after that, we move on to the problem statement for this group assignment. So number first is the power plant explosion caused by the pipeline burst violates industrial safety ethical standards and disgrace for legal requirements and safety procedure raises moral dilemmas, highlighting the need for review of procedures, accountability frameworks, and ethical obligations. And the second is the breach of pipeline pressure regulation necessitates and ethical analysis of norms governing human health and environmental protection. Balancing corporate interests with ethical duty requires a culture revolution, incorporating ethical principle into business operation, decision making, and organizational culture. And the last one, addressing the explosion aftermath requires a morally sound strategy, including through investigation, strict safety procedure, and primitive action. A culture of ethical behavior, checks and balance, and open communication is crucial for safety, environmental preservation, and community confidence. So in the objective, we have been highlighted four objectives as the main focus for this group assignment. For the first one is to explain the benefit of ethic codes words to prevent any accident at work. Second is to clarify any type of root cause in safety culture. Third one is to explain the guidelines and improvement strategy based on issue rise from this accident. And the last one is to explain the organization who responsible for handle issue at the scene of an accident. So that's all from me. I will pass to the next presenter.
Hi, my name is Ahmad Shahidi bin Rosli. My metric number is DD220080. I will present for literature review. The first is function of ethics code. A power plant's responsible and environmentally friendly operation depends on the establishment of a strong code of ethics within the facility. Next, all employees engaged in the operation of the facility are guided by the concept of integrity, transparency, and environmental stewardship, which are emphasized in this code. A power plant's code of ethics provide an essential framework that directs staff behavior and decision making, stressing the value of honesty, security, and environmental responsibility. Next, employees of the power plant are guaranteed to uphold the highest level of integrity, professionalism, and responsibility in their work. And last, to prioritize environmental stewardship, safety procedures, and the welfare of both the surrounding community and employees. A solid ethical foundation is necessary in the context of a power plant, where the operation and maintenance of intricate machinery and system are crucial. The next is code of ethics in power plant. First, safety and health. Strict attention to health and safety regulation and a dedication to moral behavior are essential in a power plant. It is imperative that workers adhere strictly to established norms and protocols in order to guarantee a secure workplace. Next, second, environmental responsibility. Environmental responsibility is of utmost importance. It is regulated by a strict code of ethics that emphasizes sustainable practices and reduce ecological impact to lower emissions, improve energy efficiency, and encourage the use of renewable energy source. This code requires the adoption of cutting-edge technologies. Third, transparency. Respecting transparency code of ethics is essential to ensuring ethical and responsible operation in a power plant. This code includes the promise to be transparent with all parties involved, including employees, local communities, and the governmental entities, and to engage with them and reveal pertinent information. The next code of ethics in power plant is compliance with law and regulation. Adherence to legal and regulatory requirements is crucial at a power plant to guarantee the facility's safe and responsible functioning. The plant's code of ethics incorporates ethical conduct and directs all employees to follow the law and industry best practice. Next, integrity. As a registered professional, is required to maintain morally upright behavior and provide professional service with integrity. Honesty and dependability are prerequisites for integrity and cannot be compromised for one's benefit or gain. And the last is conducting professionalism training. It is essential to inculcate in the staff a thorough awareness of industry specific norms and law, with conducting professionalism training for managing big project and maintaining code ethics at a power plant. It is imperative to prioritize the cultivation of a culture character characterized by honesty, security, and responsibility, in which staff members has the abilities to handle intricate tasks in an ethical and effective manner.
Okay, next I will explain about the methodology. Firstly, we talk about how the vapor explosion occur in the Kaohsiung and its effects. Okay, on 31 July 2014, there was a large explosion in the city of Kaohsiung, Taiwan, caused by a leak from underground pipeline transporting liquid propylene. Over several hours, witnesses reported smelling a gas and the same white smoke coming from manhole in the area. Next, around 11 p.m. that evening, multiple large explosions occurred across several city streets, destroying infrastructure and vehicles. Caused many injuries, with over 300 people injured and 32 died reported. Emergency service from across the region responded to help with rescue effort and put out fire, but firefighters were killed and two went missing. Next, identification of the leaking gas and effort to find the source of the leak were delayed. The surrounding neighborhood and hospital were significantly impacted by the casualties. Next, the surrounding area suffered severe damage. Next, the timeline of the event leading to the explosion. This timeline shows that the event that led the explosion in question, Taiwan in detail. We can see that before the explosion occurred, signs show that the pipeline that was out of the control at 2043. Next, at the 2046, the resident reported while the fog from the Asian question RD junction. Next, at 2050, LCY found no flow from pipeline. Next, at 2052, the firemen arrived site spraying the water. Next, at the 2055, pumping out by CGTDC. Next, at the 2105, a city gas supplier arrived site but denied the leak. Next, at 3115, Kaohsiung MRT arrived but denied any connection. Next, at 2130, Kaohsiung EPB arrived and the gas sample taken. Next, at 2140, valve shut off and pressure holding test start. Next, at 2145, Kaohsiung PWB arrived, confirmed only city gas line nearby. Next, at 2150, EPA specialist team were called for help. Next, at 2154, Taiwan CPC was called but denied any pipeline nearby. Next, at 2245, LCY ordered to resume pumping but flow abnormal remained. Okay, next, at 2220, small explosion occurred 1 kilometer away. Next, at 2235, EPA team performed analysis on thought of trench but no response. Next, at 2250, large vapor cloud found in the light rail site. Next, at 2320, CPC and CPDC confirmed pipeline nearby. Next, at 2323, CGTDC fireman sense propylene leak in Quajan RD. Next, at 2330, EPA team confirmed leak gas to be ethylene or propylene. Next, at 2335, CGTDC fireman stopped pipeline pumping. Next, at 2340, manhole found with suction sound. Next, at the 2357, at the same day, the explosion occurred. Next, the timeline of the event leading to the explosion. This timeline shows that the event that led the explosion in question, Taiwan in detail. We can see that before the explosion occurred, signs show that the pipeline that was out of the control at 2043. Next, at the 2046, the resident reported while the fog from the Asian question RD junction. Next, at 2050, LCY found no flow from pipeline. Next, at 2052, the firemen arrived site spraying the water. Next, at the 2055, pumping out by CGTDC. Next, at the 2105, a city gas supplier arrived site but denied the leak. Next, at 3115, Kaohsiung MRT arrived but denied any connection. Next, at at 21:30, Kaohsiung EPB arrived and the gas sample taken. Next, at 21:40, valve shut off and pressure holding test start. Next, at 21:45, Kaohsiung PWB arrived, confirmed only city gas line nearby. Next, at 21:50, EPA specialist team were called for help. Next, at 21:54, Taiwan CPC was called but didn't any pipeline nearby. Next, at 22:45, LCY ordered to resume pumping but flow abnormal remained. Okay, next at 22:20, small explosion occur 1 kilometer away. Next at 22:35, EPA team perform analysis on thought of trench but no response. Next at 22:50, large vapor cloud found in the light rail site. Next at 23:20, CPC and CPDC confirm pipeline nearby. Next at 23:23, CGTDC fireman sense propylene leak in Quajan RD. Next at 23:30, EPA team confirm leak gas to be ethylene or propylene. Next, at 23:35, CGTDC firemen stop pipeline pumping. Next, at 23:40, manhole found with suction sound. Next, at the 23:57, at the same day, the explosion occur.
Okay, now moving on to the discussion part whereby we're going to see the improvement or recommendation that can be done to allow and improve the code of ethics for engineers so that we can prevent this further explosion, which is the propylene explosion in Kaohsiung, Taiwan. So firstly, engineers must be compliant with laws and regulation. Second, engineers must have integrity and honesty. Third, engineers must have ethical decision making. Fourth, engineers must have high skills and competence. And fifth, engineers has ethics towards the environmental responsibility. Next, moving on for the detailed explanation for each improvement on the ethical code. So for the first part, we can see the engineers must be compliant with laws and regulation. This can be achieved through strict operation discipline that must be rooted into every operator and manager, such as, for example, safety training can be done weekly to engineers to ensure that they follow the correct SOP for gas line or gas pipeline operation system. Third, manual standards or book can be used as a set of guidelines to improve the disciplines of engineers. Engineers should obey the OSHA, which is the Occupational Safety and Health Regulation, to strengthen their discipline and also work ethics. So there are two types of clause we can see, which is a general duty clause and hazard communication standard. This can be used as a reference. Second, remove the engineers must have integrity and honesty. Correct information on the underground pipeline and trench is crucial for on-scene emergency in case there is leak. Engineers and management must engage with one another to provide accurate data of scene strategy and proper solution to mitigate risk in chemical plant pipeline operation. Further, we're going to see the engineers must have ethical competence. This to ensure that engineers must undertake tasks for which they qualified on their education, training, and experience. They continuously have to update their knowledge and skills to stay updated with the current technological advancement. Third, should have a strong grasp of a fundamental theories and data analytic skills to complement and analyze if there is any problem or leakage that's occurred in plant to find the proper solution. For the fourth part, engineers must have ethics towards environmental responsibility. This means that engineers should develop and implement effective waste management system to minimize the generation of hazardous and non-hazardous waste. Engineering designs and procedures should incorporate ecologically friendly and sustainable methods. For example, engineers can conduct deeper research on the pathway of pipeline construction with proper inspection to prevent any interaction of the gas in the pipeline with the environment that can lead to ignition cause or explosion. Fourth, we can see is engineers must have ethical decision making. This means that engineers must have accurate and fast response to decision-making process. This allow engineers by applying these ethics, this allow engineers to prioritize safety, health, and loss first rather than profitability of the organization or company. Decision-making process must comprehend and benefit both sides, which is from the perspective of the engineering sector and also the community relevant to the technical, social, economic, and environmental factors. Next, we're going to move on to the life cycle model of underground pipeline for reference guide of the ethical code for engineers. The previous case shows that the improvement in terms of ethical code of engineers during work progress. Now, we're going to go deep into the application of ethical codes or improvement of ethical codes in the life cycle of underground pipeline. So, the life cycle of underground pipeline construct deep in chemical plant has four, which is planning and design, construction, maintenance, and inspection. So this section explains in detail the proper ethical code for engineers in chemical plant based on the life cycle model, so that we can prevent the repetition of the gas explosion that happened in the Kaohsiung, Taiwan due to propylene leak. So and then comparing this misconduct incident and suggesting each improvement for the each of the life cycle model. Okay, now for the first life cycle model, we can see to the top left table is the planning and design. So what is the problem that is related to the planning and design? Usually in chemical is domestic regulation for underground pipeline plant designs is not detailed and limited. So in case of this ethical code, disobeying ethical code in the Kaohsiung gas explosion, this is due to where serious problems of graphic management and lack of three-dimensional information of underground pipeline by the engineers that causes failure of the location, the leakage of the gas pipeline along the city. So the improvement that can be done by the engineers in terms of ethical code by planning and design method is first, smart plant software helps to provide detailed design and components to instrumentation of pipeline. So the smart plant software is similar as like a SolidWorks simulation, but it is much more for the pipeline design. Next, uh, GIS helps to verify the stratification and position of the underground system. So GIS is actually geographical information center, which is helped to determine where the position of the pipeline operation along the city. For example, in Kaohsiung, Taiwan, the GIS helps to locate if where the pipelines of the networking of the pipelines throughout the city. So third, process flow diagram. Engineers can use process flow diagram as an overall view profile to approximate or outline the entire pipeline network of the plant, so that they can help engineers and technicians to determine the approximate, not the exact, but the approximate location of the leakage point. Okay, next, for the construction, we're going to see in terms of the problem whereby there is a domestic laws that pertaining to the building of subterranean pipelines, lack of common standard bill which is below the standardized code. This means that there was the construction process that usually occurs in pipeline operation is not based on the standardized code. So in case of the Kaohsiung incident, at gas explosion site, the 4-inch propylene pipe was enveloped inside the drainage culvert. Not only the patch was found, but also there were signs of corrosion throughout the layer. So improper material selection also led to this explosion of pipeline. So how we can improve improvement strategy by engineers by the ethical code is that enforcing structure and material inspection by quality and assurance engineer. For example, applying flare and operation permission before construction according to the constructability oriented planning. And then engineers also should review the status of pipeline material to ensure that the materials or components are according to standard, high quality and high grade. Secondly, engineers should supervise the construction site of the pipeline, such as the pipe fitting, blasting, painting. They should analyze each detail of the pipeline so that it meets with the design and specification that is needed, and also it provides safety to the surrounding. So for the part cycle is the third life cycle stage, which is the maintenance. So usually what relates to ethical code of problem engineers is that most of the engineers will only do maintenance of the underground pipelines inside the plant rather than outside the plant. Why? This is because for inspection to occur outside the plant, which is not within the authorities of the agency, within the inside the chemical facilities. They requires a lot of permission, paperwork, and also permission from local authorities in order to access public areas for excavation, in order for maintenance of the pipeline. This will incur a lot of time and money. So in this case, related to the Kazyong gas explosion, there was actually less notice on the operational flow pressures of the input and output ends within the propylene pipelines, which is within the facility and out of the facilities provided by the engineers. There was no proper schedule for maintenance of the damaged pipeline. So furthermore, there was also lack of input and output database that is provided by the engineers. So this is the reason that led to leakage of the propylene gas within the pipe that leads to explosion. So how engineers to improve the ethical codes is that they can establish a cloud platform of operation showing the real-time information instantly. They also have to do a preparation of maintenance plan with proper schedule, right, whereby according to the maintenance record, checking the data also formed by using a technology known as the RFID, known as the radio frequency identification, to check the last scheduled maintenance or update the current schedule of piping components. So the RFID is like a barcode which will be tagged to each equipment in the plant, so the engineers can use and scan the barcode, whereby this barcode will provide all the information of the previous progress or status that is being done to the piping or the equipments. Last but not least of the life cycle stages is inspection. So usually the problems that is related to the ethical code of inspection is that most of the engineers will not pro- conduct a proper inspection process from the beginning till end. So the Kazyong road, especially this takes place outside of the facilities. So usually the Kazyong road excavation management regulation and petroleum management law are no express provision. This is related to the case of the Kazyong. So from this improper inspection, what happens is that the engineers did not conduct proper inspection of pipeline, whereby the entire pipeline uh, inspection was done between 1991 and 1997, which is inside the facilities and outside the facilities. So, so local inspection, whereby only in the engineers only will focus the inspection within the plant and not outside the plant. So hence local inspection could not be used to detect the potential leakage area. Where did the leakage happen within the pipeline that leads to explosion? So what is the improvement that can be done? Engineers should conduct inspection in three categories, which is pre-inspection, during inspection, and post-inspection schedule to continuously update the pipeline condition. RFID also can be used to confirming indeed the visit of inspector by using cameras equipped with GPS to position each of the checkpoint or photos of evidence that's need provided by the engineers to show the proof that they already done the inspection process. For the inaccessible areas of pipeline, they can use ultrasonic gauge by measuring the thickness and the lifeline of the pipeline, so that there is a continuous update within the facilities of pipeline and outside the facilities of the pipeline, so that maintenance can be done, that helps the maintenance process can be done instantly and on the spot if there is any damage that is occur based on the data that is being analyzed by the engineers. Next, moving on to the conclusion, the confined vapor explosion of the propylene gas pipeline downtown of the Kaohsiung city was analyzed in detail. At least 90,000 kilograms of propylene was leaked, entering the underground trench and spread to the surrounding of the city, that leads to explosion with injuries and death tolls. The root cause analysis of the gas pipeline explosion was due to lack of ethical code in obeying the law and regulation in chemical plant by the engineers. Ethical code is very important and must be followed strictly by engineering technologies to prevent any catastrophic event and improve the process flow in the chemical plant. So that's all from our group. Thank you.